Assalamu alaikum. This is the third part of Introduction to Vectors, the third day here. And you have a homework. Last time we took, how can I, let's go back a little bit to the words, the vocabularies. We took the meaning of vector. Where is my pen? Okay, we took the meaning of vector, initial, terminal point, standard, direction, magnitude, and last lesson we talked about quadrant and a true bearing. We said the true bearing should start from north, and the quadrant, no, you can start from anywhere else. Now, today, inshallah, we will continue our lesson. We take some of these words. Let's start together. Before that, we'll solve the homework. 5 girls only, boys? Let's see. Okay. So R equal 30 meters of bearing of 45 degrees west of north. Do you remember? West of north. Let's graph it here. We said I will start from the coordinate plane. I will start from the origin. Can you tell me, please, from where I have to start? What about this color? Okay. I have to start from north going to the west. This is the west. This is the north, east, and south. So I have to start from north going to west with an angle equal 45. Did we forget something? Yes, I forget that R is 30. And 30, you can't represent it, it's a huge number. We said that we should write a scale. So what if you write, instead of 1 centimeter, each 1 centimeter, it will represent, let's say, 10 meters. If I have 30 meters, how many centimeters we have? Yes, 30 divided by 10, and the answer will be 3. This means that the length or the magnitude of this vector should equal 3. Who has the right answer? Bravo, excellent. Let's start with the second one. T equal 150 yards. Oh, this is a huge number. Of course, we need a scale before we continue. Okay, so each 1 centimeter, what do you want to represent? Let's say 150. It's a huge number. What if you choose for each 100 meter, 1 centimeter? Again, this is optional. Whatever you want to choose, choose. But what if I have 150? 150 divided by 100, the answer will be 1.5. So which one is easier, representing 150 or 1.5? Yes, of course, 1.5. Let's continue the question. 40 to the horizontal, 40 degree. I told you last time, if you said the word, if you see the word horizontal, this means you have to start from this east. Starting from this east. Let me change the color. Okay, what about this red? This blue, sorry. Okay. So, again, I will start from the horizontal with angle equal 40. This means this is 40. This should be equal 40 degree. Now, can you tell me what's the length of this or the magnitude of this vector? Yes, it's 1.5. Who has this answer correct again? Good. Now I want you to put for yourself a mark out of 2. Next time tell me how much did you take. Okay. Let's see now our vocabularies. Equal vectors. Equal vectors means I have A and B. Look how can we write the vector A, the vector B with this dash here. We read it vector A. Vector A. Don't forget, vector A. And here, vector B. Now, we said that vector A equal to vector B if they have the same magnitude. Magnitude, again, this is the distance or the length and the same direction. Can you see? Of course, they're both in the same direction. From this, I can know. And they both, sorry, from this also, they are in the same direction, both of them, and they have the same length. So we call these equal. Negative vectors. Negative vectors, they have the same the same magnitude, but different direction, opposite direction, not different, opposite direction. This is so important. Opposite means if one is going up, the other should go down. If one is going left, the other should go right. Okay? So can you see this? The arrow is going here, up. The second one, the arrow is going down. But they are equal. They are equal in the length, in the magnitude. They are equal, but different direction. Do you see this? This is not the value of the function. This is negative, means the direction is the opposite. Opposite direction. This is so important, okay? So this negative means for the sign, not for the length. Okay, collinear vectors. Collinear means the vector is in the same straight line or parallel. Can you look here? This vector is collinear with this vector. They are on the same straight line. And it's of course the same direction. Now this vector is collinear with this vector. They are parallel. And this vector, let's take another color. This vector is also collinear with this vector. They are parallel. So collinear means same, they are on the same straight line or parallel. Both of them is correct. Okay, coplanar vectors means they are in the same plane. We will take later if we have a 3D shapes, 3D shapes. So now we are still here in the same plane with 2 or 3 vectors. If they are in the same plane, we call this coplanar vector. Of course, we will take this in details later. Now, null vector. Null. The word null means 0. This is so important. A vector which magnitude is 0. So that's what we mean by null. Means if we have 2 equal vectors and opposites. Opposite means in the opposite direction. If you add them, the answer will be 0. Let's take example here. If a rope is pulled by 2 equal forces by 2 men, it means we have a rope here. This is the first man, and this is the second one. They are pulling for each sides, and their forces are equal, but opposite signs. This means that we have equilibrium forces. The force, the resultant force will be 0. That's what we call it null vector. Okay, let's start now with the resultants, which we talk about now. We have 2 ways to find the resultants. First, I will give you the methods, then we'll take example. The first method is a triangle method. This is so important. Tip to tail. Tip to tail. Let's see what's the meaning of tip to tail. We have this vector A and another vector V, and we want to find the resultant of this. I guess you took it in physics, anyhow. Resultant means I have to move one of the vectors to translate it, so the tip of the first one, or the tail of the first one, this is the tail, should touch the tip of this one. Again, this is the tail of B, touch the tip of A. So again, we have one tip, one tail, together, they intersect together. Now, can you see this, the green line here? This is the resultant. This one. We started from the initial point of the first one to the terminal point of the second one. This is the resultant. So now, do we have a triangle? Yes, I have a triangle. And this triangle, I can find the length of each one using ruler or using trigonometric ratio, which I told you have to memorize, right? So, of course, we'll take examples, don't worry. So, the resultant here, we took again the first vector. This is the tip of the first vector, and this is the tail of the second vector. we stick them together to get the resultant, which A plus B. I hope it's easy. Don't worry, we'll take examples. Now, the second method, which the parallelogram method. And here, tail to tail. Do you see the difference between them? One of them, tip to tail, the second, tail to tail. What color we can use? Let's take this one. Okay. What does this mean? This means I will translate this vector, I'll drag it and put it here. Same direction, don't change the angle. The angle is so important. Now I have two. Can you see this? I'll erase this one. 1 minute. Okay, let's do it here, down. Can you see this here? We drag this vector to this. We stick the two tails together. How is it? Okay, we stick. If you can't remember the meaning of tail and tip, maybe initial points are easier. This is initial point to the first one with the initial point with the second one. This is terminals, and this is initial. Maybe this is easier. Okay, so I will continue now the parallelogram with the same angles. Now, this diagonal is the resultant. Again, we draw it here. This is the resultant, A plus B. In our lesson today, we will take how can I measure it using ruler, normal ruler, okay? How to find the magnitude. Next time, inshallah, we'll take another thing. Let's start with the first example. Okay, problem word, good. So you can practice the problem words. Let's see. While hiking in the woods, Shelly walks 2 kilometers west, 30 degrees west of north. Do you remember this? West of north means we are starting from north, 30 degrees west from north, 2 centimeters instead of 2 kilometers. This means that we put a scale. Each 1 centimeter, 1 kilo. So if I have 2 kilometers, this means how many centimeters? Yes, exactly 2. So the length here is 2 with 30 degrees. And be careful, this is in standard position. Standard position means we're starting the origin. This is my first vector. The second one, 2 kilometers directly east. Sometimes you will see this directly east. Sometimes you will see horizontal. Be careful, they are the same. So directly east means this is the second vector. I start from the origin. Directly east means on the x-axis to the east. Now, what's the length of this? Again, 2 kilometers, and 2 kilometers we found it as 2 centimeters. If you use here this scale, on the other one, you should use the same scale. Don't change the scale. Clear? Again, if you use this scale on the first vector, the second one you should use the same scale. Now what he asked us to find, how far and at what quadrant bearing is Shelly from here come? This means I want to find the resultants. And we will use the two ways, the triangle and the parallelogram. Let's start with the first one. Do you remember when we said we have to drag or to translate this vector to this? So I can match the two tails or the two initial points. Let's take another color and see what will happen. What colors? Different? Okay, let's see this one. Okay, so I will drag this, put it here. It's fine. I hope it's clear. Now we have tail to tail. What does this mean, tail to tail? Yes, excellent, parallelogram. This means I have to continue the parallelogram. Be careful, please. When you continue, you should use the protractor. This means that if we have this angle, should equal this angle, which I'll draw it here. Can you tell me how much is this angle? This is 30, and this is what? 90, exactly. So 30 plus 90, how much? 30 plus 90. Good, 120 degrees. Okay, So this, I continue this part. I guess the color is not clear. Okay, this color. And continue again this. This is parallelogram. Let me erase the first one. It's not clear at all. Okay, let's see. I'll use blue. Let's see. This is the first one. Be careful with the angles. If your graph is correct, you will have the direct answer. We finish the parallelogram. The vector here, the diagonal, is my resultant. This is my resultant force. Okay. Now, how to find what is the magnitude? Again, we will use the ruler. If you use the ruler, you will find this is 22. You have to check this angle by protractor to see how much. Now we are using protractor and ruler. We didn't use the second way. Now this is the triangle way. We are sticking one of the tips with one of the tails, the initial with terminal to find. I will use it now. This is what we use today or now. Anyhow, I will show you again. This is the first one. I'm repeating so you can understand. This is the first one with 30 degree, and here we have 2 centimeters. The second one here, again, this is 2 centimeters, and it's directly to east. And I said you have to continue the parallelogram. This means that whatever you have to draw up, it should be parallel to this down. So let's choose another color. Let's see. So this should be parallel, and this is these 2 parallels. This one with this one are parallels. So we will have the angle here should equal the angle here. Anyhow, if you connect between these 2 points, this is my resultant. This is using the parallelogram. How is that? I hope it's easy. This is my resultant. Can you see? Okay. Now let's see again the rules. The parallelogram, we have the initial points together. The triangular law, with head to tail. This is head to tail. Okay? Do you want to try? Solve it using triangle method. I'll give you 1 minute. Try to solve it. Finish? Really? Is it difficult? Let's see. The first one, here we have, if you remember, this is 30. Now, if I put it here, this means that the tail with tail or the initials together. I don't want the initial together. I will drag this line down. I will drag it up. I translate it up. So the initial will combine with the terminal up. Okay, so this means that I will take it up. I will put it in another color so you can see what I mean. Okay, let's see. I will take it up in parallel ways, so we will stick them here. Please be careful. The length here is 2, the length here is 2. It's a must. Okay? This is horizontal parallel to the x-axis. This is horizontal parallel to the x-axis. This means I am using the same angle. Okay? The last step now, I will erase now the original one. No need for it. This is the original. I will erase. Then I will draw the resultant. Continue this. Use another color to draw the resultant. What colors you want? Okay. So this is my resultant. Almost. Okay. If you use the ruler, you will find that this is 2 and the angle here is 30 degrees. Clear? I hope it's clear. So what did we do? I drag one of the vectors, so the initial point of this one connect with the terminal point of the other one. This is the triangular method. I hope it's easy. Now this is your homework. You want triangular method, you want parallelogram, you will have the same answer. You can find the length, you can find, okay, if you want to find the length, and if it's difficult to find it using the video or to find the length, you can choose the length which you want. For example, if you want here 2 and here 3, it's up to you. Okay? At least I want you to understand the way how to do it. Thank you. Have a nice day.